In this video, we're going to talk about Module 1, Topic 1, Lesson 1. So don't forget to write your name on your notes, class period, and the date. So by the end of this video, you should be able to answer these questions in complete sentences. How do you determine the dimensions of a matrix? How do I use a calculator to solve a system of equations? And what are the steps on your calculator? So this video will cover how to use the iPad calculator. There will be a separate video showing you how to use a handheld calculator. So if you have a handheld, once we get to that part, you will switch over to the other video. If you are at home, you will be able to use your iPad. So if you are at home, or even if you're not at home, what I need everybody to do is I need everyone to go to their self-service app, okay? And you're going to type in TI Inspire, and I want you to download this red one right here. Mine says reinstall. I want you to download that, and that is the calculator we're going to use when we're at home. Okay, it models our handheld. So here we go. In this video, we are going to talk about a system of equations, and we've talked about how cumbersome those are to solve by hand. I know how much we don't enjoy them. So what we're going to use instead is a mathematical object called a matrix. This is going to make your life easier. So a matrix or matrices is an array of numbers composed of rows and columns. A matrix is usually designated by a capital letter. The dimensions of a matrix are its number of rows to its number of columns, and a square matrix has the same number of rows as columns. So, if we're looking at this, okay, we have a picture. What this tells us is that rows are horizontal and columns are vertical. So, our rows in this case are horizontal. So this is a row, this is a row, this is a row. So these are all the rows. They are horizontal. Then we have our columns. Our columns go vertically. So these represent our columns. Okay, now each number in a matrix is known as a matrix element. We can denote specific elements in a matrix by using this notation right here. That notation is A sub ij, where I tells us what row number and J tells us what column number. So if we look at question number 1, we have the Fleet Feet shoe store in your town just got a new shipment of Phantoms, a top-selling running shoe. They are available in sizes 9 through 13 and in width C, D, E, and double E. The manager of the store keeps track of the inventory according to the number of pairs of shoes in each size and width using the matrix shown. Describe what each row and each column represents in the terms of the problem situation. So look at this. What does our columns represent? Or let's start with our rows. What do our rows represent? Okay, remember these represent our rows. So our rows are showing how many shoes are in each width size. So let's write that out. Each row is the number of shoes in each width. So then what does our columns represent? Our columns, each column is the number of shoes in each size. So what are the dimensions? Well, how many rows do we have? We have 4 different rows. And how many columns do we have? We have 5 different columns. So this is a 4 by 5 matrix. Now, part C, which is on the next page, but we need that matrix still, says determine the number that is in each location. Describe the meaning of the matrix in terms of the problem situation. So we have element A sub 3, 4. So we want to find the third row in the 4th column. 3rd row, 4th column is number 7. So that means that we have 7 shoes in size 12 with E. Then we have the element 4, 5. So we go to the 4th row, 5th column. That is 2. That is telling us that we have 2 shoe sizes in 2 shoes in the size 13 with double E. The last one we have is element 2, 1. Element 2, so that's row 2, column 1. That is telling us that we have 5 shoes in a size 9D. Okay? So now we're moving on. How can we use this in a different situation? Well, now we have Coach Tyrone's team is at their first track meet. The finishing places and number of medals earned for 4 of her sprinters are displayed in matrix A. So that's this matrix. So we have 4 people. We have Lauren, Carrie, Megan, and Aaron. And we have how many times they won 1st through 5th. Then in matrix B, that tells us the points. So they get 10 points for 1st place, 8 points for 2nd, 3 for 6th, 4 for 4th, and 2 for 5th. What we want to do is determine each sprinter's score for this track meet. So let's start with Lauren. I'm going to use L for Lauren. Lauren won 3 first places, so she's going to get 10 points for each one of those, so 3 times 10. She has 2 second places, so she gets 8 points for each of those. She has no third places, so third place of 6 points is going to be multiplied by 0. She has no 4th places, so that would be 4 points times 0. And then she has no 5th places, so we would multiply that by 2. So when it becomes 0 or when there's 0 places, you don't have to write it. You can skip over it if you want to, but if you need to see it, write it. So how many total points would Lauren have? That would be 38 points. So then we have Carrie. She has no first place wins. She has 2 second place wins. She has no third place wins, 1 4th place win, and 2 5th place wins. And that would get her a total of 24 points. For Megan, she has 0 first place wins, 1 second place win, 3 third place wins, 1 4th place, and 2 5th place wins. So when we multiply that and add them all together, she would get 34 points. And then lastly, we have Aaron. So see if you can do Aaron's. Pause the video, check to see how you do. So Aaron has 2 first place wins, 1 second place win, 0 third places, 1 4th place, and 1 5th place. She would get a total of 34 points. Okay, so now what we want to do is we want to record the sprinter's overall scores as a 4 by 1 matrix. That means 4 rows, 1 column. So essentially all we're going to do is list all of their points in one single column. Okay, then it says label the rows and the columns. Well, this row right here represents Lauren. we have Carrie, we have Megan, and Aaron. The column represents the points. Okay? Now, when you determine the matrix representing an overall score for each sprinter, you actually performed a process called matrix multiplication. We just didn't call it that in the beginning. In order to multiply matrices, the number of columns in the first matrix must be the same as the number of rows in the second matrix. That right there is super duper important. So what that is saying is that if I have this 2 by 4 matrix, when I multiply it by something, it has to start with 4 rows. So if we look at matrix B, notice matrix B is 4 by 2. When you multiply a matrix, the columns and the rows, columns in the first one, rows in the second one, have to match. In order to multiply, those have to match. And then your answer, your result, will end up being a 2 by 2 matrix, the outside numbers. Okay, so 2 by 2. So A and B can be multiplied because the columns in the first one match the rows in the second one. So real quick, let's grab our calculator. So I'm going to switch over to the calculator. I like to start with a new document to start fresh. So just to show you, if you want a matrix, you're going to hold this button down and select the one with a lot. So matrix A was a 2 by 4. So I'm going to switch this to a 2 by 4. And I'm going to type in matrix A. So I have 1, 0, -5, and 3. Then I have -2, 1, 4, and 7. Then I'm going to type in matrix B. That was a 4 by 2. 4 by 2. So then I'm going to type that in. -3, 0, -1, and 2. Then I have 2, 1, 5, and 0. And look at our answer. It is a 2 by 2. Now, a different thing I want to show you is that if you reverse the order, the answer will actually be different. So what that looks like is if I switch the order and I do a 4 by 2 first and type in -3, 0, -1, and 2. And then I type in 2, 1, 5, and 0. And I go to type in my second one, which was a 2 by 4. That gives us 1, 0, -5, and 3. That is -2, 1, 4, and 7. I press enter. Notice that it's completely different when you switch it. So what that means is that these are not where you can switch it. It does not have that commutative property. Okay, so that's just some extra free information. So, I'm sorry, that's my dog in the back. He's not liking the storms. Let's keep on going. Okay, so now, recall that for any number n, the multiplicative inverse is 1 over n. Because the product of n and 1 over n is the multiplicative identity, or 1. Okay, similarly, when a matrix is multiplied by its inverse, their product is the identity matrix. And depending on the size of the matrix, that determines what the identity matrix is going to look like. So, in this case, if it's a 1 by 1, it's just 1. If it's a 2 by 2, it's 1, 0, 0, 1. If it's a 3 by 3, it's 1, 0, 0, 0, 1, 0, and 0, 0, 1. Essentially, ones are going down the diagonal, okay? Now, if it's not a square matrix, it does not have an inverse, okay? So, What we're going to do is we're going to use matrix multiplication to determine whether the two matrices are inverses. So in part A, we're going to multiply C times D and see if we get a inverse, which is going to look like this one right here because it's a 2 by 2. So switch back over to our calculator, hold this button down, get us a matrix. It's a 2 by 2. Let's type them in. Okay, there's my first matrix. Repeat the process. Okay, so when I multiply this out, I do get that identity matrix. So let's go here. And so what we're going to write is C times D is equal to 1, 0, 0, 1. Okay, so yes, these are inverses. Okay, so now we're going to do the same thing with G and H. We're going to see if they're inverses. So here we go. We have our matrix, and it looks like these are 3 by 3 matrices. So all we're going to do is we're going to plug in the numbers for them. So let's go through and do that. Okay, type in the second one. Okay, press enter, and notice here we get something that is not the identity matrix because that last row has -3, -3 in 2 of the columns. So let's go ahead and write that down. So G times H was equal to 1, 0, 0, 0, 1, 0. It looked real good until we hit -3, -3. So these are not inverses. G and H are not inverses. Okay, because we didn't get what we wanted. Now, we have 3 new types of matrices that we're going to talk about. So the first one is the coefficient matrix. This is a square matrix that consists of each coefficient of each equation in the system of equations in order when they are written in standard form. So what we have to do is we have to make sure that we list our coefficients in the same order for every row. X's, then Y's, then Z's. Numbers in front of X's, numbers in front of Y's, numbers in front of Z's. If we're missing a variable, then we put a 0 in its place. So if we look at this right here, what we want are the coefficients. So we have 1, +2, -2. Then we have 2, -1, +1. Then we have -1, 3, and 2. Notice my X's are with X's, my Y's are with Y's, my Z's are with Z's. That is what they're calling a coefficient matrix. Okay? Now the next part. It says the variable matrix is a one column that represents all of the variables in the system of equations. So for this, that means that our variables are X, Y, Z. So X is on top, Y is on bottom, Y is in the middle, Z is on bottom. And that is our variable matrix. these are going to be equal to the constant matrix. And a constant matrix is a matrix in one column that represents each of the constants in the system. So essentially, what is it equal to? So these are equal to -8, -1, and 13. And this is how you set up a matrix equation. So why don't you pause the video and try the second one? So if you tried the second one, I'm hoping that maybe you got stuck. Maybe you figured it out. But let's see. So the first row isn't too bad. We have 3, 2, 2. But the next one is where I expect us to get tripped up. Notice that we have x and y on opposite sides. We have to get everything to one side. And so what that does is it gives us 5x plus 4y. There's no z, so I'm going to put plus 0z, and it's actually equal to 0 as well. So we have 5, 4, 0 since we didn't have a z. Then we have -1, 2, and -1. So we have that. Then we have our variable matrix. So our variables in this are x, y, and z. And last but not least, it's going to be equal to our constant matrix, which is 4, 0, and 12. Okay, so now what we can use this for is we can use this to help us solve a system of equations. Now you will no longer have to do it by hand. Okay, but there's two different types of solutions, or there's three different types of solutions and two that we need to talk about because these will result in error messages in our calculator. Okay, we have stuff called many solutions and no solutions. The same error message is going to pop up for both solutions. So what we have to remember is this part right here. And this part right here, it's telling us that many solutions are when you look at the coefficient matrix. So look at this right here and notice these two columns. To get that middle column, what happened is they took here and they multiplied it by 2. Oh, I'm sorry, I highlighted the wrong one. Let me restart that. Oops, let me undo that. Okay. So actually it is this one and this one. So what they did is they multiplied by 2. So 1 times 2 is 2, 5 times 2 is 10, -2 times 2 is -4, and 3 times 2 is 6. That is many solutions. Okay, no solution is when there is one number that is off. So looking at the same part right here, okay, notice now they tried to multiply by 2. 1 times 2 is 2, 5 times 2 is 10, -2 times 4 is -2 times 2 is -4, but now 3 times 2 is 6, not 7. So that one little mistake is why there's a no solution. Okay? So what we're going to do is we're going to write each system of equations as a matrix equation, and then we're going to calculate the solution to each system of equations by using technology with matrices. What we need to know right here is to solve, we're going to do A times X equals B. That's our matrix equation, but to solve it in the calculator, we're actually going to take A inverse times B. And I'm going to show you what that looks like. So here we go. Let's set up our matrix equations first. So we have 2, -3, and there's no z. We have no x, 1y, 1z, 1x, 2 y's, and 4 z's times the variable matrix, x, y, and z. and it's going to be equal to the constant matrix, which is 7, -5, and -17. Now, when we type this in, we're going to type in A, and we're going to do its inverse by having a -1 as an exponent, and then we're going to multiply it by B. So let's switch over to our calculator. Let's go ahead and do this. So we started with a 3 by 3 matrix. So let's type them in. Okay, there's my 3 by 3. Now I'm going to take it here and do -1. That is A inverse. Then we're going to multiply it times our 3 by 1 matrix. And we have 7, -5, and 17. We press enter. Oop, I typed something in wrong. Okay, so I didn't do a -17. So here's what you do. If you type it in wrong, you just go up and highlight, press enter, and then you can go edit and make that a -17, and we get our answers. So I'm going to write that out. So the answer we got in our calculator is 5, 1, and -6. And so how you would write that as an ordered triple is 5 is your X, 1 is your Y, -6 is your Z. So we have that answer right there. Okay, now go ahead, pause the video, try B, C, and D, and then come back and check your answers. Okay, so here we go. We have 5, 1, 3, -1, -2, -1, 2, 4, 2. Our variable matrix, X, Y, and Z. Then we have our constants, -16, or 9, -16, and -30. So let's go ahead and type that in. We have a 3 by 3. Times, make sure you do A inverse. And then we're going to multiply it by a 3 by 1. Press enter. So I made another mistake when typing it in. So let's see, where did I make the mistake? I did not make that one negative. So always double check what you're typing in. It's easy to make a mistake. Okay, that's what I wanted. So notice we get an error message. This error message means that you can have many solutions or you can have no solution. So what you have to do is you have to go back here and you have to double check. What we're double checking is our rows and our columns to see what we multiplied by. So what it looks like is we took this one right here and we multiplied by -2. -1 times -2 is +2. That works. -2 times -2 is +4. That works. -1 times -2 is +2. That works. And here's the issue. -16 times -2 is not -30. So what that means for us is that this is a no solution. Okay, so let's keep on going. So let's write our matrix equation. So we have 1, 2, 4, -4, 3, 1, 3, -5, -1 times our variable matrix equal to -7, 19, and 17. So now we go to our calculator to do A inverse times B. So here we go. 3 by 3. We have 1, 2, 4. 1, 3, -4. 3, -5, and -1. Do our inverse. So if you just need the inverse, you would press enter after that. Then we're going to multiply it by a 3 by 1. And that is -7, 19, 17, double check, and we get this. So if you get fractions, you can always list fractions, but if you want decimal, hold down the enter button, get the squiggly lines, and there's the decimal versions. So I'm just going to write this as an ordered triple. That was -3.5, 1.5, and -1.5. And that would be our solution right there. Okay, one last one. So here we go. Let's set up the equation. So we have 2, there's no y, -3, 2, 1y, -5, no x, 3y, -4z. Then we do our variable matrix. We have x, we have y, we have z, equal to our constants. -4, -1, not -4, it's a +4. So let me fix that. -1 and 2. Okay, all we got to do is type it in. So we have a 3 by 3. We have a 3 by 1. And what did I forget? Can you find the mistake? Forgot to do A inverse. So I'm going to go over until my cursor's in the middle. I'm going to hit that exponent button, do that -1 for A inverse, press enter. And this time I'm going to leave them as a fraction, but if you want to convert it to a decimal, you can just by hitting that. But I'm going to write down the fraction answers. So this is 59/4, 12, and 17/2. Okay, so there we go. We have that right there. Okay, and so by now you should be able to answer the essential questions. And if you want to see a video with the handheld calculators, I will not be going over everything, but I will be going over the basic of what we just did at the end. So if you have any questions, write it down. And again, if you want to watch the calculator video, go watch that one.